And my project is on predicting churn for a digital health app. A little bit about my background, so I can give you some context for why I chose this project. I have a pretty varied background. I worked in investment banking, international development, the climate change that person was me. And in the last 10 years, I've been really focused on healthcare, digital health technology, and also nutrition coaching and counseling for people with chronic disease. And so I'm really passionate about how technology and data science can be used to help people change their health behaviors to lead healthier lifestyles. And so I feel very, very fortunate to have been able to do my project on this app called Diabesties. It was built by a Canadian health app developer called Yogo in partnership with the College Diabetes Network. Diabesties was designed to help college students with type 1 diabetes better manage their condition by allowing them to track their blood glucose, their insulin, and their carbs, etc. And importantly, be able to then share that data with a friend or diabestie who could help to keep them accountable and give them support. So that's where the name Diabesties comes from. Now, my project, as I mentioned, was to predict user churn, which means that I'm trying to predict in advance who is going to stop using this app and who is going to continue using this app. Now, why is this important, you ask? Well, if you can figure out in advance who is going to stop using the app, then you can try to intervene to get them back on track and therefore improve your usage and improve the stickiness of your app. Here's a quick snapshot of some of the technologies that are used. And now let's get into the project. I received the full 3 years of data as it ran from 2012 to 2015 on the iPhone App Store as a MySQL database. In this data, I had about 3,000 users who had logged their data about 50,000 times, and in some had about 400,000 clicks or page views in the app. So first of all, let's figure out what we can learn about the users from the data. Here's the first most surprising finding. 70% of the users were not actually college age. The average age was 37, and in fact, some users claim to be in their 80s. And secondly, now not so surprising, about 42% had type 2 diabetes versus type 1. Type 1 is an autoimmune condition that occurs in childhood, which is why in college students with 18-year-olds with type 1 diabetes, versus type 2, which occurs later in life. Now, it was hard to really pin down the ethnicity and location because a lot of people didn't specify, but from the data, it's probably fair to assume that most people were Caucasian and living in the United States. Now, what can we learn about how users interacted with the data? So even though users could track a lot of different things, they mainly use this to track their blood glucose before and after meals. So that's not so surprising, and occasionally they track insulin and mood and carbs and other things. Now, this is also very interesting. 85% of the users used the app a few times and then stopped. And there's really this core group of 10 to 15% of users that used it diligently day after day, and some over a period of 2 to 3 years. And finally, what was the effect of having a diabestie? It turns out the effect was pretty minimal. Having a diabestie didn't really impact churn. In fact, it was kind of 50-50 who churned versus who didn't. And even the number of people that had a diabestie was only 3% of the total users. So as you can see that the app was used quite differently from the way it was actually intended, and its users, many of its users were different from the intended target audience. So now that we've seen a little bit about the data, let's get to the fun part. Can we predict anything from this data? So I used a combination of user data and behavioral data to run my models. Okay. I defined churn specifically as users who stop using, who use the app for less than 10 times after the first week of use. Okay, so if you used it a couple more times, didn't really count. You're not really engaged with this app that you're really supposed to use multiple times a day. Here are the models I ran: logistic regression and 3 different decision tree ensemble models. Okay, now drum roll, how did they do? Which one won? So this is a handy graph. If you see, it's called an ROC curve, and the models with the most predictive power are kind of towards that top left corner. And so you can see it was pretty close, but a gradient boosting trees really kind of were a bit better than the other models. Okay, so that looks interesting. Now let's dive into some of the results. Accuracy of 94%. What does that mean? It means that 94% of the time, the model could accurately classify who churned versus who didn't. So that sounds pretty good. Precision of 95%. That means that 5% of the time, you had people predicted that they would churn that really didn't. So let's say you made 100 calls trying to get people on track. 5 of those people would have stayed in because you wasted your time. Right? Oh, wait, what happened? Oh no. It's okay, for a second. Did I do something?
No, you didn't do it. Just not now. There we are.
I'm going to start doing some memory. Okay, all right. Here we are. Okay, we're back. So, recall of 98%. What does that mean? 2% of the time, people that were going to churn were classified as not churn. So, you have 2% of people kind of slipping through the cracks. So, that sounds good, but is it? Let's have a closer look at the confusion matrix, and the confusion matrix doesn't lie. The confusion matrix is telling us, look, that's figure 692. Those are the people that were predicted to churn that did churn. Great job. And there are only about 16 of these people that were wrongly classified. But this model seems to do a pretty good job of predicting who will churn. What if you wanted to predict people that aren't going to churn? So in that case, it's really about 50-50. It's no better than a random guess when you have that 34 and 28 down there. But if all you care about is who's going to churn, maybe that doesn't matter. It really depends on your business use case. Also of note, a lot of the literature said that for churn modeling, how users interact with the app is more important than their demographics. And this pretty much bore out in my models. Out of the top 5 features in terms of their importance and prediction, only one of them was related to demographics, and that was age. So the key takeaways and next steps. First of all, like I said, how an app is actually used can really differ wildly from how you intended it to be used, and you really have to be cognizant of that when you're building your model and as you continue to build out the app. And then behavioral data has more power, seems to have more predictive power than demographic data. So that really means if you can really get people to engage in that first week, that could improve your churn numbers. And I hope that these results can help IOGO better plan the data collection and modeling for future apps. Thank you for coming, thank you for listening, and thank you to IOGO for letting me do this project with their data.
Excellent project. How large was the number that churned versus didn't in terms of the actual number who churned, number who didn't? How large was the training set? Both.
Gosh, I can't remember off the top of my head. I think out of 3,000, there were about 500 that didn't churn. So it's a pretty imbalanced cost.
So if you could speculate, how much of an impact, if any, do you think that might have on your conclusions? Since it was like 95% true positive, but like you had some interesting numbers in terms of false negative, true negative rates.
I think it means that if you want a model that's going to help you to predict churn, and it's kind of a softball in a sense because the classes are so imbalanced, then fine. But if you want to predict who isn't going to churn, then this model doesn't do a great job of that. And really, I think we need a lot more data to really come up with a better model. And maybe play around with the features some more and try different things. So looking at, that didn't use the app at all after 1 week, what about after 2 weeks, what about? And they basically all came up with pretty similar results.
All right, thank you.
I was going to ask if you could go back to the feature slide. Those are interesting. And then could you tell us how you...
This one?
Yeah.
That one.
Can you tell us a little about some of the features there? And then
Sure.
the behavior ones that were...
Behavior
It's very interesting.
Sure. The number of page views that a person made in the first week, and I really clumped a lot of things together and called it a page view. the number of entries and glucose entries they made in the first week, their age, the number of times they wrote a note, the number of times they recorded a mood. And I understand there might be some collinearity between notes, moods, and entries and page views, but the notes and moods were not, you know, they didn't, it's pretty relatively small, and it wasn't really one-to-one. And then the type of college that they went to, they college, other, or high school, you know, because these are dummy variables, so there are a bunch there. Gender, ethnicity, type 1 versus type 2 diabetes versus other, which is probably gestational diabetes. And that was really about it. Yeah.
This is very interesting to see.
Is there anything that you would have done differently, or just?
You know, the stuff that I do is that we do URL analysis. So it was interesting you lumped all of the page views together into one feature, but you could have actually done one per page.
It's a mobile app, so.
When they weren't capturing. Okay.
No, they didn't. There wasn't, and you know, they built it a few years ago. And they said, "Hey, I'm really sorry, we didn't totally set it up for this, but good luck with the data."
No,
So, but that's.
You can actually get any sort of conclusions that I think really interesting. You can actually get conclusions that are like not the best data to provide.
Yeah, I was afraid there'd be no signal, but you know. But anyway, but it was still, you know, I want to do something with diabetes, and it was just an interesting exercise, and that's what Capstone is about. And thank you very much.